Good morning. So today's topic, functions. Definition. So function is a special type of relation. Okay. Let us take two non-empty sets, A and B. Let us take two non-empty sets, A and B. The rule between the elements of A and B is called a function from A to B. Right. The rule between the elements of A and B is called a function from A to B. If to each element of A there corresponds exactly one element of B. Okay. Example. Let us take a function f of x is equal to x for all x belongs to set of all natural numbers. So f of 1 1, f of 2 2, f of 3 3. Right. So I can define x 1 to 10. Right. Therefore one 2 3 4 5 6 7 8 9 10. Okay. A and this is B. The function is f of x is equal to x. So 1 maps with 1, 2 maps with 2, 3 maps with 3, 4 maps with 4, 5 maps with 5, 6 maps with 6, 7 maps with 7, 8 maps with 8, 9 maps with 9, 10 maps with 10. Right. So this is a domain and this is codomain. Domain, codomain. If you see, each and every element of domain is mapped with each and every element of codomain, and the element of domain will have only one image in codomain. So another one example, let us take one birthday date. Okay, birthday date Jan 1. So on this date, on Jan 1, so n number of children might have born, right? We are taking a person X, Y, Z. I am taking Jan 1, right? X also born on Jan 1, Y also may born on Jan 1, Z also may born on Jan 1. I can take another one date Jan 2. Is there any possibility for this X to born on both the dates Jan 1 and Jan 2? So it is not possible. So X maps with Jan 1, right? So X cannot map again with Jan 2. It is not possible. Right? So it can be possible if it is a relation. In function, it cannot be possible. Each and every element of domain will have only one image in codomain. But this Jan 1, this image, this element may act as image for one or more elements of domain. Okay, so I think hope you all understood the definition of function. Next, types of function. Types of function. First one, one function. One or injective. One function or injective function. So the definition: a function f such that a tends to b is said to be 1 1 when means if distinct elements of A have distinct elements of B. Distinct elements of A have distinct elements of B. Okay. Example, simple example I am taking. F of x is equal to x for all x belongs to integers. So I can substitute f of minus 1, answer is what? Minus 1. I can substitute 0, answer is 0. I can substitute 100 also, answer is what? 100. That means different elements of A is giving me, is mapped with different elements of B, right? So the condition. So how to prove this one condition means, if it is given, let f of x1 is equal to f of x2. Okay. So here the condition is what? F of x is equal to x. So I can get what? X1 is equal to x2. If f of x1 is equal to, this is our assumption, okay, x1 and x2 belongs to what? The given. Here it is given what? A. So x1, f of x1 is equal to f of x2. Therefore, we will get the answer x1 is equal to x2. Right. Next. So this is one function. Next, many one function. Next one is many one function. A function f such that a tends to b is, so if it is not satisfying 1 1, that means, let me tell you, a function is said to be many one when means, example, f of x is equal to x square for all x belongs to same integers. So f of 1 value 1, but what about f of minus 1? Again the answer is 1. Okay. Here x1 is 1 and x2 is minus 1, that is x1 is not equal to x2, but f of x1 is equal to f of x2, right? So therefore it is not 1 1. Obviously what? Many one, right? So if a function f such that a tends to b other than 1 1 function, other than 1 1 function, then it is called what? A many one. Okay. So I am going to take 1 and minus 1. So both maps with what? 1. So f of 1 1. F of minus 1 also what? Minus 1 raised to the power 2, answer 1. So both 1 and minus 1 takes the same image, same element as image. Okay. That means 1 is acting as image for 1 as well as minus 1 of domain, right? So this is not 1 1. This is not 1 1. This is many 1. This is many 1. Right. Next, onto function. So onto function or surjective. Okay. A function f such that a tends to b is such that each element of b, that means the element of codomain, is the image of at least some element of a. That means f of a is equal to b. That means all the elements of b will be acting as image. Therefore, range of that function will be equal to codomain. Okay. Since all the elements of codomain are mapped, that means they will act as what? Range. Okay. One same example, f of x is equal to x. Okay. So for all x belongs to z or r, your wish, whatever it is. Okay. Suppose I am taking one more function, f of x is equal to x square. Okay. For all x belongs to integers, right? So now f of minus 1 answer 1, f of 1 answer 1. Okay. That means in codomain only the positive numbers are mapped. That means no negative number is mapped, since it's an exponent, even exponent, right? So no negative numbers are mapped from codomain. So therefore this is not onto. Okay. Example. So this f of x is equal to x is an example for onto for all x belongs to z, and I am taking another one example, f of x is equal to x square for all x belongs to set of all integers. So it's an example for not onto, right? Next, so based on this, suppose if a function satisfies both 1 1 and onto, so that function can be called as bijective function. Okay. If a function is injective and surjective, if it satisfies injective condition and surjective condition, we can call it as what? Yes, it is bijective function. So let us take one example. To prove f of x is 1 1 but not onto, so a function is given f such that n tends to n, right? And function f of x is equal to, it's a polynomial function, x square plus x plus 1. We should prove that, so this f is 1 1 but not onto. Okay. So to prove 1 1, first 1 1 condition. To prove 1 1 condition, let x1 comma x2 belongs to, here domain and codomain, both domain we should take set of all natural numbers. Let x1 comma x2 belongs to n. I can assume f of x1 is equal to f of x2. F of x1 is equal to f of x2, right? So what is the function? X1 square plus x1 plus 1 is equal to f of x2, x2 square plus x2 plus 1. I can cancel this 1 and 1. Okay. Now x1 square minus x2 square plus x1 minus x2 is equal to 0. So using the identity, so a square minus b square, I can write it as x1 plus x2 into x1 minus x2 plus x1 minus x2. So this is this term, okay, which is equal to 0. So from both the terms I can take this x1 minus x2 as common, x1 minus x2 common. So x1 plus x2 plus 1 equal to 0. So with the condition this thing, so x1 plus x2 plus 1 not equal to 0, I can take x1 minus x2 is equal to 0. So x1 is equal to x2. Since I am getting x1 is equal to x2, therefore the function f is 1 1. The function x is 1 1. Next for onto. Next we should say onto condition. It is not onto, right? That we are going to prove. Okay. So let that f of x is equal to y. Okay. F of x is equal to y for all y belongs to n. So the given is y is equal to x square plus x plus 1. Now this x square plus x plus 1 can be written as x square plus x plus 1 minus y equal to 0. I am going to get x value. We know the formula, factorization by formula, Sridharacharya's formula. X is equal to minus b plus or minus root of b square minus 4ac whole divided by 2a. So for the quadratic polynomial ax square plus bx plus c, so identify a, b, c value. So a value 1, b value also 1, c value is 1 minus y. Apply. So minus 1 plus or minus root of b square, 1 square, 1 minus 4 into a value 1 into 1 minus y whole divided by 2 into 1. Okay. So minus 1 plus or minus root of 1. So minus into my, so shall I multiply the minus 4 inside? Will become minus 4 plus 4y whole divided by 2. So therefore minus 1 plus or minus, so what I will get as answer means square root of 4y minus 3 whole divided by 2. So what we are getting actually, I am getting a fraction. So if I substitute y value as 2, what I will get as answer? If I substitute 1, I will get answer 1. If I substitute, suppose let y equal to 1, right? Since it belongs to natural number, if I apply like that, what I will get answer means, if I apply 1, so the answer is x is equal to minus 1 plus or minus, so 4 into 1 4, 4 minus 3 1, root of 1 1 by 2. So answer I will get 0, which does not belongs to natural numbers. Okay, so which does not belong to set of all natural numbers. Therefore we can conclude that therefore function f is not onto. That means that y value, sorry, that x value is not belongs to set of all natural numbers. Okay. So we can say that when I substitute y equal to 1, I am not getting natural number. Suppose if I substitute y equal to 2, right? So x is equal to minus 1 plus or minus root of 4 into 2 minus 3 whole divided by 2. So minus 1 plus or minus root of 8 minus 3 by 2 minus 1 plus or minus root 5 by 2. So what I am getting means I am getting an irrational number. Therefore when y equal to 2, x not belongs to set of all natural numbers. That means 2 is an element in codomain. Two is an element in codomain, but that does not have, but 2 does not have pre-image in domain. Okay, when I substitute 2, that means 2 is not mapped with any element of, what is the meaning? 2 is not mapped any element of domain. Therefore f is 1 1 but not 1 2. Okay, thank you.